Hi guys, this is Swapnil Singh from Miss BJ's Period 3 Honors Physics class. And the physicist we're discussing today is Dennis Gabor. Okay, so let's start with his early life. Dennis Gabor was born in Budapest, Hungary on June 5, 1900. He showed his affinity for inventing at an early age and received a patent for a carousel using real tethered airplanes at 11 years old. This was the first of many he would receive in his lifetime. After serving in the Hungarian artillery for World War I, Gabor began his college education at the Technical University of Budapest and later at the Technical University of Berlin. After graduation, he steadily developed his interest in electron optics. Due to his religion, though, Gabor was forced to flee Nazi Germany to Britain in 1933. There he married Marjorie Butler and obtained a British citizenship. Leading up to holography. Mercury vapor lamp. So this was during his time in Germany. Gabor made his first significant scientific contribution in 1927 while working for Simon and Halske in Berlin. There he invented the molybdenum tape seal, a key improvement to the mercury lamp. There were no coherent light sources for Gabor to conduct his holography experiment, though, so he made do with mercury vapor lamps as his light source. A coherent light source is a monochromatic light source from a single point and of a single wavelength. So these were lasers, and those were not invented until 1960. So he had to use mercury vapor lamps, although they were not as accurate for his results. Okay, so this is in Britain. There he worked on the electron microscope. During his time as a research engineer for the British company Thomson Houston, the microscope distorted the image of atomic lattices, and the solution to the problem remained elusive until Gabor had the brilliant idea to use a diffraction pattern. The idea was to take a distorted electron picture and clarify it with optical means. This concept is what helped him develop holography. Diffraction is the bending of waves that occur when an object encounters an obstacle. Okay, so this is the actual holography part. So what is holography? The definition is the recording and reproduction of exact spatial structures of an object through the use of interference patterns of a coherent light source. Again, a coherent light source is a monochromatic light source from a single point and of a single wavelength. Gabor also coined the term hologram from the Greek word holo, meaning whole, and gramma, meaning message. Okay, so let's see how a holographic picture is taken. So you have your laser, which is your coherent light source, and it goes through a beam splitter, which splits it into the object beam, which is over here, and the reference beam. So the object beam directs directly from the mirror onto the object and then onto the holographic plate. So this is what gives you your picture, okay? And the reference beam reflects from the mirror onto the holographic plate. It doesn't touch the object, but it does cause an interference region with it, okay? And the interference region contains the intensity and phase information about the object. So every point on the laser touching the object is reflected onto the holographic plate. Okay? Yeah. And this is, if you looked close enough on the plate, this on the bottom over here, this is what you would see on it. Like this kind of pattern. Alright. Okay. What are the uses of holography? So one really great use is it is a really effective data storing method. Even pieces that have been cut off from the original film effectively show the entire hologram. So if I took a film and cut it into 4 parts, each part would show the entire hologram, not just 1/4 of it, like a photograph. So it's more effective than a photograph, but it is more time consuming and more, yeah, it's harder to make, basically. Then there's art where you can see over here, 3D movies, and this Japanese Vocaloid called Hatsune Miku. Okay. His other contributions are the Gabor limit, the Gabor atom, the Gabor filter, and granular synthesis. So the Gabor limit, the Gabor atom, and Gabor filter, he worked on like as he was developing holography. And the granular synthesis came afterwards. Okay, it still had to do with waves because he was researching sound. So later life. Gabor published works about holography include Nature, Proceeding of the Royal Society, Proceeding of the Physical Society. So these are all after he patented holography in 1947. This work earned him a 1948 position on the staff of the Imperial College of Science and Technology of London. In 1958, he was promoted to Professor of Applied Electron Physics, and he held that post until his retirement in 1967. He died in Britain on February 8, 1979 at 79 years old. And these are the list of awards he achieved during his lifetime. One of the most notable ones is the Nobel Peace Prize in Physics for his invention and development of the holographic method. Okay. Thank you for your time, and these are the sites I used.